So we're asked to solve this equation given that one of its roots is an integer. So here I have a cubic. So what I'm going to do is I'm going to put in numbers like, say, sub in z equals 1, maybe z equals minus 1, z equals 2, z equals minus 2, until I find a value that satisfies, that equals 0. So that's how I'm going to find my integer root. So I'm going to sub in, so z equals 1 will be 1 cubed minus 2, 1 squared plus 5, 1 plus 26 equals 0. So I'm just going to plug that into my calculator and see what I get out. And I get a value of 30, which is not equal to 0. So 1 is not a root. So I'm going to try minus 1. So it'll be minus 1, minus 2, minus 1, minus 1 plus 26. So that's going to be minus squared. Sorry. So minus 1, minus 2, minus 5 plus 26. So that's 18. So that's not equal to 0. So that's not going to work. So minus 1 doesn't work. So I'm going to try 2. Sub that in and see if that works. So 2 cubed minus 2 squared plus 5, 2 plus 26 equals 0. So, sorry, can you see there? So I'm just subbing in 2 for z, and I'm going to see if this satisfies the equation. So I'm literally just subbing into my calculator, and I get a value of 36, which is not equal to 0. So 2 doesn't work. So I'm going to try minus 2 and see what I get here. So let's see if this works. So everywhere I had a 2, I'm going to plug in a minus 2. So minus 2 will go here, and minus 2, and minus 2. So there we go. And 0, when we plug in minus 2, we get an answer of 0, which is equal to 0. So minus 2, so minus 2, so z is equal to minus 2 is a root of this, is a root. So you know what I can do now, if I want, is now that I've figured out that x minus 2 is a root, I can go and divide my equation by x minus 2, and then I should get, so if I divide my equation, so z minus 2 is a root, so z plus 2 is a factor of the equation. So what I'm going to do now is I'm going to divide my cubic by z plus 2 to get the other two factors. So I'm going to do long division. I'm going to do long division divided by z plus 2. So z into z cubed goes z squared by z is z cubed, z squared by 2 is plus 2z squared, and then I'm going to minus the second line, so that's minus 4z squared. That's going to be minus 4z, minus 4z squared will go here, and then minus 8z. I'll bring down my plus 5z here. Then I go to minus the second line, so I'll change the signs of everything, so they'll cancel. I'll be left with 13z, and I'll bring down my 26, and then z into 13. 13z goes 13 times, so 13z plus 26. And then I'm after figuring out the z. So this is my other factor. So I'm just going to go on to a clean page if I can find one. So 1 second. So I'm after getting a new page here. So that's so from my previous work. So z minus plus 2 I've established as a factor by z squared plus 13, and that's equal to the equation which I'm after getting. So that's equal to this. So, but this, I'm not going to be able to find the roots for that. So I'm going to have to solve this, I can use the minus b formula. So if I'm going to solve this for z plus 13, I can go minus b, so it'll be plus 4 plus or minus b squared, which is minus 4 squared. So minus b plus or minus b squared minus 4, and it's going to be a c, which is 13, all over 2a, which is just 2. So it's going to be 4 plus or minus 16, and then 4 by 13, sorry, 4 by 13 is equal to minus 52, all over 2. So it's going to be 4 plus or minus the square root of 36 of minus 36, sorry. And because it's a minus square root, we can split that up to, you know, it's going to be complex roots. Square root of 36 by the square root of minus 1. And we know that the square root of minus 1 happens to be I, so that's 4 plus or minus square root of 6i over 2, which is equal to, which is equal to 2 plus or minus root 3i. So our factors are z is equal to 2 plus 3i, z is equal to 2 minus 3i, and we're also after figuring out that z is equal to minus 2, and we were asked to solve the equation, and we got z is equal to this, this, and this. And we noticed that if a polynomial has real coefficients, which it did, if one complex number is a factor of it, the conjugate is also a factor, and we see that here. So that is our answer. Thank you.